Hello everyone, myself Dr. D. Malati, Assistant Professor from the Department of Science and Humanities, Chemistry Division. Here we are going to discuss about the topic external conditioning, that is ion exchange process or demineralization process. First, we should know about the hardness of water. Hardness of water means the water which does not produce lather with soap. Depending upon the types of dissolved salts present in water, hardness of water can be classified into two types. First one is temporary hardness. Second one is permanent hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium. It can be removed by boiling the water or by adding lime to water. Second one is permanent hardness, and it is due to the presence of chlorides and sulfates of calcium and magnesium. It cannot be removed by boiling the water, but it can be removed by using lime soda process or by using zeolite process. This hardness of water is very important in industrial uses because it forms scale in heat exchange equipment boilers. Water used for industrial purposes should be free from hardness producing substances, suspended impurities, and dissolved gases, etc. The process of removing hardness producing salts from water is known as softening of water or conditioning of water. Softening of water can be done by using two methods. First one is internal treatment, second one is external treatment. In this we are going to see about the topic external conditioning or external treatment. It involves the removal of hardness producing salts from the water before feeding into the boiler. The external treatment can be done by using two processes. First one is demineralization process or ion exchange process. Second one is zeolite process. In this we are going to see about demineralization process. In this process, it removes almost all the anions and cations present in the hot water. The following two types of ion exchange resins are used. First one is cation exchange resin or cation exchanger. Second one is anion exchange resin or anion exchanger. And the demineralization process is carried out by using ion exchange resins, which are long chain cross linked insoluble organic polymers with a microporous structure. The functional groups attached to the chain are responsible for ion exchanging properties. In cation exchanger, the resins containing acidic functional group, that is COOH, SO3H, are capable of exchanging their H plus ions with other cations of hot water. Cation exchange resin is represented as RH2. Examples are sulfonated coals, sulfonated polystyrene. Second one is anion exchanger. Here the resins containing basic functional group, that is NH2OH, are capable of exchanging their anions with other anions of hot water. Anion exchange resin is represented as ROH twice. Examples are cross-linked quaternary ammonium salts and the urea formaldehyde resin. Next, coming to the process. In this process, the hot water first passed through the cation exchange column, which absorbs all the cations like calcium, magnesium, sodium, potassium, etc. from present in the hot water. The cation free water is then passed through anion exchange column, which absorbs all the anions like chlorine, sulfate, bicarbonate, etc. present in the water. And the water coming out from the anion exchanger is completely free from cation and anion. This water is known as demineralized water or deionized water. And the reaction which is taking place in cation exchange column is shown here. Here it is cation exchange resin is usually represented as RH2, and it reacts with calcium, magnesium and sodium, and it forms RCa, RMg and RNa. And the reaction which is taking place in anion exchanger is shown here. Usually the anion exchange resin is represented as R-OH twice, and it reacts with HCl and sulfuric acid, and it forms R-Cl2 and R-SO4. Regeneration. When the cation exchange resin is exhausted, it can be regenerated by passing a solution of dilute hydrochloric acid or dilute sulfuric acid. Similarly, when the anion exchange resin is exhausted, it can be regenerated by passing a solution of dilute sodium hydroxide. Advantages of anion exchange process. Here the highly acidic or alkaline water can be treated by this process. The water obtained by this process will have very low hardness. And the disadvantages of ion exchange process are water containing turbidity, iron and magnesium cannot be treated because turbidity reduces the output and iron and magnesium form stable compound with the resin, and the equipment is costly and more expensive chemicals are needed for this purpose. Thank you.